So today we are going to start with resistors in parallel. Our topic of discussion is resistors in parallel. Last class we have seen resistors in series. So let us see the first example here. As you can see here in this 3 ohms and 9 ohms both are connected with a battery. So battery is here, this is positive and negative. Always remember current flow from terminal that is positive to the terminal that is negative. So current will flow like this. Now pay attention here. As the current start moving from positive, it will reach to this point. Let us name this point as A. Okay, so when the current reaches point A, to reach the negative terminal, there are two paths. One is this path and another one is this path. So basically there are two choices for the current which is coming from positive terminal to the negative terminal. So one is this and another one is this. So whenever the current divides, that combination is parallel combination. Now how to solve it? So we can write here, so we can solve the equation 1 by r is equal to 1 by 3 plus 1 by 9 is equal to, taking the LCM as 9, so it will become 3 plus 1, that is equal to 4 by 9. So 1 by r is equal to 4 by 9 and hence r is equal to 9 by 4 ohms. So this is your very first answer. We can, as you see on the screen, the second questions. So again we are having a battery positive, we are having a battery negative. Current start moving from positive to the negative. As it reaches this point, again it will be divided to 10 and it moves further and reaches to 5 also, again it divided, because there are two paths to reach the negative terminal which is here. So basically it is divided and this is again a parallel combination. So we can write the answer. So we will get the answer by solving this equation, and this is 1 by r is equal to 1 upon 5 plus 1 by 10. So after solving you will get the answer, I think. So you can solve it by your own, but this is how we make the equation. Coming to the third problem, we see here positive is there, negative is there. So current move from this point. As you can see now, this is very important. Current reaches to this point. From here it will go from 4 also and it will go through this 4 also. So while the time this current reaches to this point, this current, first current which is flowing through the 4 ohms, it will go here, it will follow this path, pass through the 8 ohms and reach to the 4. So basically 4 and 8, these both are in series, while we get the answer for the series and we can solve it by 4. So we can write here like this is in series. So 4 plus 8 is equal to 12 and hence we can write our equation. So 1 by r is equal to 1 by 4 plus 1 by 12. From where this 12 is coming? Again I am telling this 4 and 8 because current is same in these both resistance. So these both are in series. So that is why 4 plus 8 is equal to 12 we are getting. So we are writing here this equation. So after solving you will get the required answer. So now one thing is clear, that whenever current starts from one point, from positive and terminates to the negative, we see how many paths it can travel to negative. So if there are a number of paths, current is divided, and because of that, so here we can write some points that current is divided in parallel. As we can see, it traveled through multiple paths. So current divides in parallel while the potential remains the same. So potential is same here because on this resistance or on this resistance it will be same. So potential remains same. How we can say? As you can see here, if here is 3 volts, so on this 3 ohms it will be 3 volts, on 9 ohm also it is 3 volts, because both are in parallel, and in parallel potential remains the same. Current divides and potential is same. So coming to the third point, formula is 1 upon r is equal to 1 upon r1 plus 1 upon r2, and don't forget to reciprocate in the last. That is very important, that we have to reciprocate it. 1 upon r is equal to 1 upon r1 plus 1 upon r2. As we can see here, it is a combination r1, r2, r3 on the screen, and there are three currents, i1, i2 and i3. So basically if the current start from potential, that is V, it goes through this, it get divided, so all three are in parallel, that is 1 upon r1 plus 1 upon r2 plus 1 upon r3, and hence it comes out and reach to the negative terminal. So this is how we can say that current is divided. Thank you.